Around 60 BCE, a ship was sailing through the straits between Crete and the Peloponnese, making its way past the island of Aegila, which until just a few years before was known as a pirate hotspot, only to have been caught in a storm. Unable to reach shelter before disaster struck, the ship sank, claiming the lives of at least 4 people. The ship was probably a large merchant vessel, measuring around 40 meters long, and it was filled to the brim with amphorae containing wine and other goods, antique marble sculptures and bronze statues, glassware, and a curious, delicate mechanical object the size and shape of a shoebox, made of wood and metal. To the untrained eye, this device would have looked like nothing more than a box of dials and gears. But to those in the know, it was an analog computer capable of calculating the cycles of the cosmos. This is the story of the Antikythera Mechanism. The remains of the shipwreck were discovered in the year 1900 by sponge divers from Symi working off the coast of the island of Antikythera, once known in the ancient world as Aegila. One of the divers, Ilias Lycopantis, dove down to around 40 meters below the surface, and when he came back up, he was shaking, saying he had seen dead, naked bodies lying on the seafloor. The captain, Dimitris Kontos, went down to check it out, and he found that these dead people were in fact marble and bronze statues scattered all around him, along with countless other artifacts. Kontos then brought up a life-size bronze arm to show to the rest of the crew, and I'm really hoping this is where Call Me By Your Name got its inspiration from. Immediately understanding the importance of what they had stumbled upon, the sponge divers began working with the Greek government and archaeologist Georgios Oikonomos to explore what had been lying hidden under the waves for almost 2,000 years. This was the first ever underwater archaeological investigation, and what they found was jaw-dropping. Apart from the impressive bronze sculptures, divers brought up amphorae from Rhodes and Asia Minor, Parian marble statues from the Aegean, glass from Syrio-Palestine or Egypt, and silver and bronze coins from Ephesus and Sicily. The coins were minted between 76 and 67 BCE, giving us the evidence needed to estimate that the shipwreck likely occurred sometime in the next decade or two after 76 BCE. From the variety of products it had on board, it appears that the ship was on its way to Rome as a merchant or cargo ship, though some scholars believe that it was filled with looted treasure. The divers pulled up approximately 100 stunning marble statues and bronze sculptures like the Antikythera Youth that dates to the 4th century BCE. To a public audience, these were the most exciting items to be coming up from the water. Eventually, the finds were becoming less and less exciting, and the year after, a telegram was published stating that a slab with an inscription had been found whose letters could not be copied. Little did they know that this slab of corroded metal and wood would later be identified as the world's oldest known analog computer. No one seemed to think much of this corroded lump, and it was actually almost thrown overboard before it could even get to Athens. And instead of investigating this further, attention at the National Museum naturally went to working with the big ticket items. Because of that though, it wasn't treated for conservation after it was removed from the seawater, which caused some deformation changes. If you want a visual example of how delicate objects that come out of salt water need to be handled, I recommend looking at scenes from Titanic or my personal favorite, Fool's Gold. But maybe don't do what they do. Get a professional to do it for you. The Antikythera Mechanism didn't stay unnoticed for long though. In May 1902, the once singular hunk of metal and wood had split into 2. There are various stories as to how this actually happened, but visiting archaeologist Valerios Stace noticed a metal gear poking out of it, along with an inscription of Greek letters. And from there, an avalanche of research began that would last over 100 years. Initial conservation and cleaning of the Antikythera Mechanism separated the slab into 3 pieces, and today it consists of over 82 fragments. 4 fragments contain multiple years, and many of the others contain ancient Greek inscriptions. To get an idea of the size and mind-blowingly expert craftsmanship that this mechanism possessed, the largest gear measures only 13 centimeters in diameter and would have originally had 233 teeth. That's some very expert craftsmanship. I don't know really how else to describe it. The first translations that were made was a phrase saying ray of the sun, leading some to believe it was an astronomical clock. This flabbergasted other scholars who believed that it must have belonged to a much later ship because this kind of technology wasn't seen until the 14th century. Over the years, more and more tiny tidbits were recognized. A Greek word for one of the ancient Egyptian months was discovered, suggesting there was something to do with a solar calendar, and the Greek word for the planet Venus, Aphrodite, meant something lunar was also involved with this device. By the 1930s, other interpretations for the mechanism had been an astrolabe and a planetarium showing the sun, the moon, and the 5 planets known to the ancient Greeks. That was as far as the research went until post-World War II, when Derek Jasala Price, a British physicist and historian of science, took an interest in it. Price realized that quite a decent amount of the original mechanism was corroded into the fragments, and that it must have had something to do with calculating time cycles with astronomical events. To him, it had nothing to do with seafaring. The mechanism seems to have just been a victim of circumstance whilst being transferred, probably to the person it was built for. Thanks to Price's persistence, the fragments were x-rayed by nuclear physicist Charalampos Karakolos in 1971, and 30 gears were identified. Price did make a reconstruction of the Antikythera mechanism based off of what he could see with the x-rays, but it wasn't the most efficient and was overcomplicated for the delicate nature of the gear teeth. You gotta give him kudos though. I'm not a jigsaw puzzle person, and this right here would have been my nightmare. It would have been the death of me. So researchers went back to the drawing board, and new studies were undertaken by Michael T. Wright and Alan Bromley in the late 80s and early 90s with linear tomography. And the most recent examination and reconstruction of the fragments began in 2005 by the Antikythera Mechanism Research Project in collaboration with the National Archaeological Museum in Athens. The research project performed CT X-rays of the fragments as well as polynomial texture mapping, which is now generally referred to as reflectance transformation imaging, or RTI, which is used to enhance the visibility of details on the surface of the object. The CT scanning was immensely helpful for researchers to figure out the internal physical and mechanical structure of all of the fragments, and it even found hidden interior inscriptions and made the visible inscriptions found on the gears and other metal pieces a lot clearer. So far, about 3,000 of the approximately 15,000 characters have been transcribed, and it appears that we have found about 30% of the original mechanism. All of this work and further research from this imaging has really helped with reconstructing what this mechanism was used for and how it would have functioned. So without further ado, let's get into it. The Antikythera mechanism was used essentially as an analog astrological computer. If you're wondering what an analog computer is, look no further than your wrist. If you have a watch and it isn't digital, that is. The mechanism would have been a box measuring about 30 centimeters high, 20 centimeters wide, and 10 centimeters deep, with rectangular bronze plates as the front and back faces. It was framed by a wooden casing and had a knob on one side to turn all of the gears. The front face had a circular dial surrounded by 2 concentric rings with different scales of measurement. The inner ring was fixed and was divided into 12 sections with markings of the zodiac symbols. Each of these sections had 30 little evenly spaced out ticks in them, and this spacing matched Babylonian astronomy in that it assigned 1/12 of the ecliptic, the path of the sun around the earth over the course of the year, equally to each zodiac sign. This means that the mechanism was used to predict eclipses based on the ancient Babylonian Saros eclipse prediction cycle, which is 233 lunar months, or just over 18 years. The second ring was actually removable and rotatable, and was marked with the months and days of the Egyptian calendar in the Greek alphabet, which is 12 months of 30 days with 5 extra days tacked on at the end. The Egyptians didn't observe leap days or years, so the year was actually fluid and moved through the zodiac over the course of about 120 years. This is why that ring had to be adjustable to account for what part of the year was in that part of the zodiac. The front dial also had multiple pointers coming out of the center. A lunar pointer that showed the position and phase of the moon with a small half black, half white ball that would have rotated both the dial and the ball itself to actually show you what the moon would have looked like. And this dial amazingly rotated according to the accelerating and decelerating elliptical pattern of the moon by the first ever known use of epicyclic gearing. That's pretty wild. The dial also had a solar pointer to mark the position of the sun on the ecliptic and to possibly point out the day of the year, and it also had the orbits of the 5 planets known to the ancient Greeks at the time: Mercury, Venus, Mars, Jupiter, and Saturn. The backside, on the other hand, had 5 dials, 2 larger spiral slots that were inscribed with scales and radial dials, and 3 smaller circular dials with little pointers. The top spiral is called the Metonic dial, and it was divided into 235 sections, each one representing a lunar month and containing the Corinthian names for the months. This equates very closely to 19 years, or the Metonic cycle, which is when lunar phases begin to appear again at the same time of the year. The Callipic cycle was also used, which is a period of 76 years. And this is just a larger version of the Metonic cycle. You don't have to get too hung up on it. These cycles were just a helpful way of converting lunar and solar years on the mechanism. The bottom spiral was similar to the top, but with a lot less writing, and used to predict not only the month, but the time and day of eclipses. Whoever was using it, though, had to pay careful attention when turning the knob, because when the pointers on the back reached the end of the slots, they had to lift out the pin and reinsert it at the beginning of the spiral to start the whole next cycle again. I could spend all day trying to go into the working mechanisms of the mechanism, but I'm still not sure I understand it fully myself. So the last important thing I'll mention about the backside is the game style. It's the only pointer that moves counterclockwise, and it calculated the timing of the Pan-Hellenic games, such as the Olympics, the Isthmian Games, the Nemean Games, the Pythian Games, and it also calculated the dates of 2 smaller games: the Games of Na and the Games of Alea of Rhodes. On top of all of this, tiny, delicate Greek text would have been inscribed around these dials in the free space of the bronze and on the front and back bronze plates that acted as covers. In fact, we can read parts of over 50 lines on the back cover inscription, and it tells us a systematic description of the outside dials of the mechanism, sort of like a user manual. The current reconstruction of the Antikythera mechanism has 69 gears working all together to move the dials on the outside, but some think there may even have been a few more thrown in there as well. In short, the Antikythera mechanism was an astronomical calculating machine where you can set a date via the calendars, and it will then show you where all the planets would be, the orbit and phases of the moon, and the eclipse cycle. When the mechanism was first identified, the initial belief was that it was used for navigation, especially because it was found on a ship. Another theory is that the device was made for demonstrative or teaching purposes, not really for astronomers who would have needed a much more precise machine to calculate fractions of days and more minute occurrences such as the varying lengths of days and nights, but rather it was probably for teaching students of philosophy and the elite about stars and the planets and their impact on Earth and within their society. The mechanism itself was too small to have been used as a teaching prop for large groups, so it was most likely for tutorials and individual lessons. This is quite the object to be used for instruction, and a bit too revolutionary just for your everyday run-of-the-mill school lesson. That's why we have the theory of it being more for small elite schooling or just for a small group of philosophers. The Antikythera mechanism is a marvel of miniature metal and mechanical work that we thought was previously unknown in the ancient world. We knew the ancient Greeks used gears, but we didn't know they used it at this level of detail and precision. These These gears were made of carefully cut sheets of bronze and were optimized to minimize friction. And it's so unique because it's the only scientific instrument that has survived the fate of most copper and bronze objects of the ancient world: recycling. It's likely that other machines like this existed, both precursors and even more finely made mechanisms afterwards, but metal was a valuable commodity, so a lot of the time artifacts like these were melted down and reused. It's probably also likely that the Antikythera mechanism itself has metal that had been reused from a past device. We know that Cicero had written in the 1st century BCE about 2 devices made by Archimedes, who was one of the greatest scientists of the ancient world, who lived in the 3rd century BCE, and he also wrote about one by the philosopher of Posidonius, who lived in the 1st century BCE, and he called them celestial globes that were able to reproduce astronomical motions like eclipses and the movement of planets. So we knew for a long time that the ancient Greeks and Romans were aware of the variable speeds of the moon orbiting the Earth, as well as this predictive gear technology. We just didn't know what a device would look like until the Antikythera mechanism came along. And now we do know that even though they could be rare, devices like these were known, and more than one was definitely made throughout history. But these devices would have taken thousands and thousands of working hours to create and cost a lot of money. So these weren't items that would have been mass produced. Archimedes was therefore probably the person to lay the groundwork and invent these analog celestial computers. The Antikythera mechanism was made sometime after the death of Archimedes, who died in the Battle of Syracuse in 212 BCE, meaning that it was likely created by a student or follower of his who was aware of his calculations. Of course, this astronomer or scientist wouldn't have worked alone, as he needed bronzesmiths and other master craftspeople to create something of this level of precision. Something like this was definitely a collaborative effort. This is what happens when everyone pulls their weight in the group project. Just saying. Based on the measurements and the inscription of the Corinthian month, the Antikythera mechanism was first thought to have been created for someone in the Corinthian colony of Syracuse. But more analysis has pointed towards the northwest of Greece to Epirus, which could have been on the ship's route while it was on its way to Rome, especially because we have the dial with the Pan-Hellenic games on it. One of the games took place in Rhodes, though, which is on the complete other side of the area, so that's another theory, especially when some of the amphoras seem to have come from Rhodes, and that the astronomer Hipparchus, who lived in the mid-2nd century BCE, lived there, and the mechanism uses his theory for the motion of the moon. Of course, like all archaeology, we'll never be sure unless we find some marking on the device somewhere that explicitly says was made in X place. Honestly, it could also have just been on its way to Rome with all of the other fancy stuff, because at the time, Rome was a big fan of Greek things, and I'm sure some rich person there would have loved to have it on their shelf. As to when the Antikythera mechanism was created, that's another issue that's been up for debate. Because it was technically a bunch of calendars, there would have needed to have been a calibration date to make all the planets go around the dial in the correct pattern. Some scholars have said that the mechanism displays some eclipses that occurred around 204 BCE, but most recently, in 2022, others proposed the initial calibration date to be the 23rd of December, 178 BCE. Remember, these are calibration and not construction dates, but this date can give us a window into the time that it was created. This means it could have been created a little bit before this date for predictions, or afterwards when they actually had some eclipses in their records that they could calibrate properly with. The very existence of the Antikythera mechanism proves that the ancient Greeks had a deeper understanding and mastery of astronomy than we could have possibly imagined. They possessed knowledge that rivaled science that was being conducted in the 16th century. Even scholars who spent their lives studying it have stated that it's a level of technology that in their mind couldn't have existed. But yet, here it is, and it is very likely, without a doubt, to have been made in the Hellenistic age. The Greeks came so close to inventing clockwork hundreds of years before it was finally invented. but due to the lack of popular documentation or continued later representations of the Antikythera mechanism or objects like it, it seems that the trend didn't catch on. If it had, it could have possibly pushed the Enlightenment and the Industrial Revolution millennia ahead. In fact, Arthur C. Clarke, author of 2001: A Space Odyssey, even said, "If the insight of the Greeks had matched their ingenuity, we would not merely be puttering around on the moon. We would have reached the nearer stars." Well, we may not have reached any stars, but the Greeks and Romans certainly knew how to bring those stars down to Earth. It's also worth noting that they chose to use this technology not to mark the minutes, but to find their place in the universe. Maybe we should take a lesson out of their book. Thanks so much for watching, you guys. If you liked that video, go ahead and smash that like button down below. Don't forget to subscribe to the channel. And if you like the channel and you want to help make a difference in it, head on over to Patreon and become a patron. You get early access to all of my videos. You get behind the scenes photos. You get some merch. You get some cool behind the scenes updates. It's all there for you. It's all happening over on Patreon. Here's all my socials. And as always, stay dirty, my friends.